For the introduction, first we introduce the composite material. It is material that is composed of two or more materials that combine the properties that superior to individual materials. It will make the new material more stronger, lighter, and durable. The example is metals and polymer. For composite plate, is a plate that made out of two or more composite material, typically arranged in a laminate configuration, created to enhance the properties of materials. Some example of use is in the industries of aircraft and spacecraft. For tensile strength and modulus. Tensile strength and modulus are both used to assess the strength and stiffness of materials. Tensile strength refers to the maximum stress a material can withstand before it fails and breaks under tension, typically expressed in units of force unit areas such as megapascal. The modulus of elasticity is a measure of material stiffness and elasticity. The modulus will tell how much some of the material deform and elongates under applied pressure and compressive stress. The units are Pascal and gigapascal. Now we move to the background study. A composite plate is a flat structure that is composed of different materials such as composite materials. Composite plate is a combination of reinforcement materials and matrix material. It consists stack and bond multiple layers called laminae. Lamina consists fibers embedded to matrix material. Fibers provide high stiffness and matrix holds the fibers together. Reinforcement material is to enhance the properties of composite material. Example is carbon fibers and fiberglass. It provides high strength and stiffness to composite material. Matrix materials are substances that holds all the reinforcement material in composite structure. Example is polymer that offer good addition to reinforcement materials and high resistance to chemicals. Now we move to the objective of study. The first objective is to determine the modulus and tensile strength by testing the plate in universal testing machine. The second objective is to find the average of modulus and tensile strength and compare to other group. There are 8 of concept of the composite plate. Firstly is the material selection. Next is design and layout. The third one is the preparing the reinforcement. The fourth is mixing and applying the matrix material. The fifth is composite plate formation. The sixth is curing or hardening. The seventh is trimming and finishing. And lastly is quality control and testing.
Next, we will talk about the methodology of our project. Firstly, we discuss the idea to choose a composite plate. Second, we choose the best idea and start doing the composite plate. Third, after finish making the composite plate, we doing the laboratory testing at Ma'amal Kejuruteraan Structure Ringan. Fourth, the leader of the group assigns tasks to each group member to finish the report. And lastly, we record the presentation video and submit the report to the lecturer. Next, apparatus and materials are tissue box, plastic, paper, scissor, ruler, and sellotape. Next, procedure of making specimen. First, tissue box, paper, and plastic are measured to 200 mm length and 20 mm wide using the ruler. Second, the composite materials are cut off by using the scissor. Third, repeat the first and second step until the composite plate is 2 mm thick. Fourth, each layer will be taped together to form a composite plate. And lastly, repeat the step 1 until 4 to make 3 composite plate sample. Lastly, procedure of laboratory test. After preparation of the sample has been complete, we have sent our sample to be tested to obtain the load value for the specimen. The test has been carried out at Ma'amal Kejuruteraan Structure Ringan, FCAP, which has been assisted by an assistant engineering named Encik Razali bin Slamet. The procedure first is a vernier caliper was used to measure each stencil specimen's diameter and gauge length for engineering strain and stress calculation. Second, data acquisition software was launched after selecting the right material. The load cell was zeroed to measure only tensile load on the specimen. Third, each specimen was carefully placed into the machine's jaws with uniform space between clamps. Fourth, the load was released and the test began after it had been confirmed that the specimen had been properly loaded into the machine. Fifth, The software ended the test and saved the data to the spreadsheet when the material fractured. The specimen was removed from the machine's jaws and the system reset for another tensile test. The second specimen underwent the same treatment. And lastly, the experimental data was used to calculate the yield stress, young modulus, and tensile strength.
Assalamualaikum and hi, my name is Muhammad Nurimabi Faizul with metric number AF220055. Now I will talk about our group data analysis and results. So data analysis, the elasticity or the other name is Young modulus, are the fundamental property for every material that cannot be changed. The Young modulus of a material is essentially its stiffness. In other words, how effortlessly it can be bent or stretched. To be more specific, the basic and numerical value are calculated as Young modulus equal to stress over strain. When data for stress and strain are plotted, we can find the Young modulus by finding the gradient of the initial section of the curve. Next, the tensile strength, which is also known as the ultimate tensile strength. We can calculate the tensile strength by using the equation P over A, where P is the maximum load and A is the cross-sectional area. So, this is our result for three samples. The first data is point 1 in the stress strain graph. Same for the point 2. Then we will calculate the gradient of the initial section of the curve where the y-axis is data for stress while the x-axis is data for strain. And this is the result for Young modulus for all of the samples. And this is the maximum load for three samples. After we find all the detail, we need to calculate the average Young modulus. And we got the Young modulus for all of the sample is 1.983 megapascal. Then we find the area and the average of maximum load to calculate the tensile strength. So the tensile strength for all of the sample is 0.097 megapascal.
Assalamualaikum. My name is Muhammad Ridwan bin Ismail and my matrix number is CF220199. Today, I will present about the discussion for our project. In order to obtain the Young modulus for composite specimen, we have carried out tensile test experiment. We provide 3 samples because there may be failed samples. When the material reaches a certain stress, the material will begin to deform. It is up to point where the material structure is stretching and not deforming. However, if you are to stress the material more than this, the molecules or atoms inside will begin to deform and permanently change the material. The Young modulus for first specimen we get 2.09 megapascal. The Young modulus for the second sample is 2.21 megapascal. The last sample is 1.65 megapascal. After that, we calculate the average Young modulus for all 3 samples and got 1.98 megapascal. From the Young modulus of these samples, we can see that there is no consistency for the material we used. Next, we will calculate the tensile strength and got 0.097 megapascal for the sample. Next, I will present about the conclusion for our project. Composites are more quickly damaged than wrought metals because they are more fragile. Case metals are frequently fragile as well. To get greater strength in composite materials, the interlayer component is the most important factor to consider. The length of time that layers are combined is also crucial. If the interlayer is not applied quickly, it is more likely to become brittle. This is because composite materials require enough time to bond layer by layer. A curing time also is required before testing. That's all from me. Thank you.